Hello, welcome back to the Visual Basic class, and this is CS 111. And today actually we are going to study the chapter 1, which is Introduction to Visual Basic 2017 Programming. In this chapter actually we will go over some basic stuff, and hopefully you have collected your books. The name of the book is here, and that's Microsoft Visual Basic 2017 for Windows, Web and Database Applications Comprehensive, and it's written by Corny Hoisington. So first chapter focuses on the basic stuff. Here are our objectives for this chapter. First of all, we will understand the software and computer programs, then these are the basic stuff, and then the role of a developer in creating a computer programs. So in this course, actually this is a computer science course, and one of the aspiring role you may get as a you may pursue as an outcome of computer science graduate is the software developer or software engineer. So we will touch base on those role of the developer. We will specify the use of a graphical user interface. The graphical user interface, what is that? If you go to a web page, it's visual, right? So you present something visual, or you go through something visual, and that web page is an example of a graphical user interface, or GUI. And we will also describe an event driven program. Simplest type of event driven program you could have experienced is that you did something on the page, and a pop-up comes up. Suppose you completed the payment on a e-commerce page, a pop-up comes up. So that's event driven, because the event is the payment and the pop-up is the message from the payment that you have paid this amount of money to certain vendor, and now whatever the message, or some error message, that's also an error. Then we will study about specifying the roles of input, processing, output and data when running a program on a computer. We will explain the logical operations a computer program can perform. Then we will define and describe the use of a database, identify the use of a computer programming language in general, and of course the Visual Basic in particular. Explain the use of Visual Studio. I'm writing here 2017, but it's not really 2017. We are using Visual Studio 2022 when we develop the Visual Basic programs. Specify the programming languages available for use with Visual Studio. We will explain the .NET framework as well. We are not going to use 4.6.2 here. We will be using .NET 7.0 or 6.0, because those are the latest version. Those are that are stable. So the version numbers from this slide and what we are actually using, they are little bit different. So pay attention to my session 1 lecture to know exactly what versions of the packages and programs we are using. But here what we are going to describe, they will be basically focused on the overview of the .NET framework. Software packages are usually backward compatible. Means if it is good, something is available in 4.6, then that should be also available in .NET 6 or 7, with some exceptions, of course. Anyways, so we will also explain the RAD, describe the classes and objects and the .NET framework class libraries, and also we will explain ADO.NET, and also we will be explaining ADO.NET, ASP.NET, MSIL, CLR, all those interesting things. we will be explaining. We will specify the type of visual basic applications. Now we started with the word RAD, right? What is RAD? RAD is nothing but rapid application development tool. You know, the it's a basically in 1970 it was conceived, but officially introduced in 1991. Rapid application development is a methodology focused on developing applications rapidly through frequent iterations and approvals with continuous client feedback. By prioritizing agile and rapid prototype releases, RAD emphasizes software usability, user feedback, a quick delivery over long-term planning, and a single initial set of requirements for building items like custom applications. So the main benefits of the RAD methodologies are reduced development time, enhanced flexibility and adaptability, much better risk management, less manual, mostly automation, and the real-time user feedback. So we will be discuss. It's related to the methodology of the application development. We will be discussed in due course of this session. So let's go to the next part, which is introduction, which is basically computer, very basic stuff. So a set of instructions that directs a computer to do certain tasks is called computer software or a computer program. On the mobile device, for example, you have a set of apps, right? So those are the computer programs. And also, if you look at your Windows 10 computer, that also has certain programs or applications or apps in abbreviated language. Now, computer hardware plays an important role in defining and building applications or apps. Computer hardware is the physical equipment associated with a computer. Okay. So as we are talking about, computer hardware is the physical equipment. This is associated with a computer. A mobile device is a portable computer hardware. So you can see on the picture, these are all zoology of computer hardware. By computer hardware, that does not necessarily mean a laptop computer or desktop computer. It means you can call hard drive as a computer hardware. You can call RAM, the random access memory storage, as a computer hardware, a mouse as a computer hardware, digital camera as a computer hardware, a printer. So many. So a mobile device is a portable computer hardware, of course. And then the basic function of many programs is to accept some form of data. When we talk about computer programming, it is helpful we think about inputs and outputs. What is input? Whatever you put inside computer as an input, basically. So the basic function of many programs is to accept some form of data, manipulate the data in some manner, and create some form of data that is usable by people or other computers. So the computers will execute a program if the program and data are placed in the computer's random access memory. Think about it. A computer has several, from the software point of view, it has several partitions. The random access memory is that when you start the computer, you put something on the random access memory, then your program and data, if they are present there, then only they will be able to talk to each other. Even if you drive the data from an external drive, let us say a USB, like the pen drive or memory stick, whatever you call it, then also it buffers the computer, the programs buffer the data and put it inside random access memory. Programs run on the random access memory, and at that place, random access memory is the place where the programs and the data, they talk to each other, they share among themselves. They are interlinked there. So your random access memory is the place where the program and data both has to be placed in order that the computer can execute a program. Okay, so the computers has another part which is called Central Processing Unit, or CPU, that can access the program instructions and the data in RAM to perform activities as directed by the program. Okay, CPU is like a brain of the computer. Now, saving or storing the data, what does it mean to save or store a data? So it means that you are placing the data or software electronically on a storage medium such as a hard drive, or maybe a USB drive, pen drive you can call it, or a cloud storage server. You know, these days cloud computing is so interesting, so popular. You can use the cloud storage server. For example, AWS is a leading vendor of cloud computing. There are Google also GCP, Google Cloud. The Google Cloud projects are there. There are many cloud computing vendors, Microsoft Azure, and so on. So the cloud storage server is also the place where the data can be stored. Then the persistent data remains available even after the computer power is turned off. For example, you store some data on your Word file, Microsoft Word file, you put your resume, and then you save the file, and then you switch off the computer, shut down the computer, and then you start it again back. Then your data will be stored. Data will remain stored inside your computer hard drive, because once you save the file, that becomes the persistent data. You know, you have to save file. So save is persistence. So once you save the data, it becomes persistent. So I'm saying it because you may think that it's okay, it's pretty much what we do in the daily life. That's absolutely right, but I'm giving this introduction to put in perspective all the element of operations that we do when we use certain applications, programs. So let's say Microsoft Word is a program, and then we whatever we write in the Microsoft Word, that is the data, and then once we save the data, that means we are persisting that data. So then once this Word file is saved, the data inside becomes persistent data, and it remains available, right? You can save the file, and later on you come back and you open the Microsoft Word program, and you will be able to see what is there, right? That's pretty much the persistent data. Now here actually we show a layout of Visual Studio program, event driven programming kind of. So you can see that button, select, pizza, click. So basically what it does is basically you click some button, and then something pops up or something executed. As it says, the code is executed when the user taps or clicks the select pizza button. So basically there is nothing important in what we are doing here. Maybe we are writing a pizza store, but that's a basic layout of a Visual Basic program that we are going to learn in this course. So I'm sharing with you a simple snippet of the program that will help you to understand the event driven programming. That's an example how we write the code and how we use the Visual Studio to write a basic code. It's a segment of the code, and that's about it. So we have given you two examples of event driven programming, units of program. We will discuss about it later. Don't freak out by looking at this code, because it is just for sharing purpose. I'm going to show you this. Does not necessarily mean that you will know about it. You may know it, but I'm not expecting you to know anything about whatever is shared in the screen. So now comes the second part, which is computer programs and developers. A computer program is designed and developed by software developers, programmers, or engineers, you can call them. Developers are people skilled in designing computer programs and creating them by using the programming languages, right? I mean, in this class we are going to learn Microsoft Visual Basic. So after completion is in this class, you will become a developer who will be skilled in designing computer programs and creating the computer programs using Visual Basic language. So applications may consist of several computer programs working together. I mean, your program does not necessarily contain only Visual Basic. I mean, it can be a collection of many languages. I mean, I'm not talking about a single program code contains different languages. No, that's not true. But you can have in your network, you can have multiple codes calling each other, multiple pieces of program modules you can calling each other, which are not necessarily written in the same languages. So developers create the program by writing its code using a programming language. Most Visual Basic programs are event-driven programs. So that is the characteristic of the Visual Basic programs, So every programming language has a specific use case or specific user story in it. So event-driven programs are most common for Visual Basic programs, and they use the graphical user interface. It consists of a window. It contains a variety of objects. We will see that. An event means the user has initiated an action. Just as I said, I mean, in the beginning of this lecture, if you remember, I mentioned about a payment processing. Someone is shopping online, and then they click a button, payment button, after at the checkout at the shopping cart, and then a pop-up comes up, and that is the event. That event means the user has initiated an action that causes the program to perform a type of processing in response to that action. Now, event-driven programs with a graphical user interface user may enter data into a program, then click a button. Just you see here, it's an excerpt from a Visual Basic program where you are having two fields, account number, and then there is an account balance. That's a label. Account number is a box, is an input box where you input the number. Remember what you do when you go to your bank account. So this is a use case of a bank account, and you put the account number, then the display bank balance. Once you do that, it will show you once you click the display bank balance button. So let's go to more elementary level. So the representation that you see on the picture, it's a graphical user interface or GUI. Now this graphical user interface has 4 different objects. You can say 4 different objects. One account number box, which is an input box where you specify your input, the account number. Then there is a label. This is also an object. Let us say this is a text object which will display your account balance. But then you have 2 buttons. Display bank balance, this is one button. Once you click the display bank balance, you should be able to see the account balance if you provide the account number, and then the refresh will give you the updated balance at certain point of time. So this is a perfect example of GUI, and this clicking the buttons are perfect examples of event driven programming. Means you are clicking a button, something happens, behind the scene your program, your program in Visual Basic, you don't know yet about how to do the Visual Basic. We all know that, but suppose we have written some Visual Basic code, but once you click the buttons, behind the scene your program will trigger some process, some workflow, and that will calculate the balance of the account if the account number is specified. A question: in the event driven programming, if the account number is not given, what are you going to do? The answer is, in that case you simply may decide as a programmer to throw an error. There will be a pop-up and it will show, please enter the account number. Those are the simple use cases. You may think about those. Now comes the input operations. It's a very important operation that most computer programs involves a user who enters the data. Whenever we write a program, you know why the programs are written? Its primary purpose is human computer interaction. So a human user that enters some data, and then the step one is that user types the account number on the keyboard. Step 2 is the data is stored in the RAM. It goes to the RAM, keyboard to RAM. And step 3 is the data is displayed on the computer screen. Do you know why? Because the screen, that account balance, it is motivated by a program. This screen is created by a program. The program and the data both are staying inside the RAM so that the program can read the data and display it on that particular input box of account number. So main requirement here is that program and the data, they both should stay inside the random access memory or RAM. Now comes the output operation. The second basic program operation is creating output or information. So here basically once you click on the display bank balance, again the program has all the information stored in the RAM, and then it does some calculation and displays the balance. So here also it sends the balance to the RAM, and then from the RAM the balance is uploaded onto the GUI. So you must be understanding the program is having some connectivity with the RAM, right? And when you write the program, it's an orchestration of different processes. So that's what the computer program is meant for. It orchestrates all the instructions so that computer can consistently follow certain operations. This is one of the examples, like you put the bank account number and click the display account bank balance, and it will fetch the bank balance stored in under your account, the persisted inside your account, and display the balance. So that's all about it. So as with input operations, a variety of devices can present the output. So computer monitors can present output, but also common output devices include printers, let's say gaming console, and the smartphone screens. Those are all popular output devices. So you can see here, the mobile devices and the printer. Many cases you will see that for example, if somebody has pets, I have a pet, a dog, very loving creature. So I go to the pet hospital frequently for him, pet store. So what happens there in the pet hospital, once they complete some transaction. Let's say my pet saw his doctor, and the doctor completes his diagnosis, writes the visit summary, then it directly goes to the printer so that the associate can go there and grabs a printed copy and give it to me for further use. Maybe the dog is vaccinated, and the user needs the vaccine certificate so that they can do the dog license. They can travel through airplane, and airplane will need to see your dog's vaccination proof. So that's why actually the workflow of the program may be that the doctor writes something and clicks some button. A doctor is the user of the program, and then the program will trigger some process by which a print will be initiated. Okay. Now in many programs, arithmetic operations, let's say addition, subtraction, multiplication, division, are performed on numeric data in order to produce useful outputs. Those are called the arithmetic operations. There can be logical operations. I mean, these are the operations that we do in the programs. First of all, we do the arithmetic operations. Let's say we do 1 plus 1 2. That's an arithmetic operation. Or you can do the logical operations, just I mean, if something is valid, then go to this. I mean, it will determine whether two values are equal, whether one value is greater than another value. Or you can say that if your user input is certain thing, like suppose the user input is a word, and if the word is approved, then you do something, but if the word is not approved, then you do something else. So those are the logical operations. The decisions, basically the decision trees embedded in the program. Then you have software and data. Those are saved. So when you develop and write a program, the code you write and other features such as the GUI must be saved on the disk. When you want the program to run, you can have the program loaded into the random access memory and executed. The program you write, however, also can save the data. So banking applications must save account data. In most cases, the data is stored in a database. We will talk about database a lot in the future. So database is a collection of the data, but that collection process is organized. That database is an organized collection of the data, so that the organization is done in a way that allows to access the data, to retrieve the data, and also to use the data, and also add the data or delete the data from that particular system. So database is a complex data handling system, you can tell. Now comes the Visual Basic and Visual Studio. Each program statement causes the computer to perform one or more operations. The developer must follow the syntax of the programming language. Syntaxes are called the programming rules. We will be talking about it. Most developers use a tool called Visual Studio 2022 to write the Visual Basic programs. So Visual Basic Studio is a type of integrated development environment. We already talked about it in our last week's session. I showed you step by step how do you install Visual Studio and write your first Hello World program. So it provides services and tools that enable a developer to code, test, and implement a single program, or sometimes many programs. So if you see the Visual Basic screen, you can see some coded statement in something like that. I mean, we will be talking about it. I'm just showing you the glimpses of the screenshots of the Visual Studio. So once you code something on the Visual Studio, you should be able to see this type of layout. Now Microsoft Imagine, the Microsoft program that supports a technical education by providing access to Microsoft software or training. learning, teaching and research purposes such as Visual Studio. So Visual Studio window looks like this, I mean, here we took a snippet of the Visual Studio program. You can see the menu bar and you can see the file, edit, view, project, build, deleting, testers, tools. I mean, all these things are the menu bars, and there is a title bar, of course. What particular program you are opening, that will go to your project we are opening, that will go to your title bar. Then you have a toolbox. Toolbox essentially contains a set of tools basically. So what are the important tools associated with the perspective that you have opened your Visual Studio for? And the middle area is the main working area. You will see all the activities there. You will see the GUI, the sample GUI, and also on the right hand side you will see the Solution Explorer and then the Properties window. Just open your Visual Studio and can you identify all these sections? I don't want you to write any code right now, but you should be able to identify different parts of the studio, at least the main working area, the Solution Explorer if you created a project or opened a project, and also some other sections, the menu bar, title bar, the standard toolbar, everything it should be visible to you. So following elements will help you to use the Visual Studio. The title bar identifies the window and the application open in the window. The menu bar contains the menus that has the lists of commands that allow you to create, edit, save, print, test and run a Visual Basic program and to perform the other functions. Standard toolbar contains buttons that execute frequently used commands such as open project, new project, save, cut, copy, paste, I mean all those things. Just open it, just open your Visual Studio and just try these comments one by one. You will find, I want you to explore these by yourself. This is so important before you start writing the code. In the last session, I know you have installed the Visual Studio. Now this week it is your turn to inspect how you can use the Visual Studio. I already demoed you something, but you should, as a developer, as a programmer, you should go into the system and start exploring the things. Now the programming languages that is supported under Visual Studio are, there are many. First of all, the Visual Basic that we are going to learn. This programming language allows developers to easily build complex Windows and web programs as well as some other software applications. So it's based on the basic language. There is a classical language in the software, in the history of software, which is called the BASIC. So it's based on the basic language. There is a Visual C++. It's the derivatives of the programming language C. Visual C# is the synthesis of elegance and syntax of C++ with many of the productivity benefits enjoyed in Visual Basic. So something like that. And then JavaScript, JavaScript first of all has nothing to do with Java. There is a common confusion. So JavaScript is an open source client-side scripting language, and also the Visual F# multi-purpose language known for its math-intensive focus. So if you talk about these languages, so what are the programming languages that Visual Studio support? The answer is many. But main languages that are supported are Visual Basic, Visual C++, Visual C#, JavaScript, and Visual F#. So the .NET framework, .NET technologies and products were designed to work together to allow businesses and to connect information, people, systems, and devices through software. The .NET framework, it gives you the tools and processes that developers can use to produce and run the programs. So most recent version of .NET is, I think it is the stablest version is .NET Framework 6, that we are going to use. 4.6.2 was the .NET most recent version when the book was written, but now it is, I think, 6 or 7. So there are multiple class libraries supported within .NET. A class is a name of group of program code. A button is an example of a class. It's an object. Basically, class is a framework of an object. I mean, the blueprint of an object. Let's say you have a building, right? The building is built out of a plan. The plan is not a building, right? Plan is something that architects make. So class is something like that. Class is it composes all the technical facts, but not in object pattern, not in the real pattern. It's a framework. It's the outline about. It's a definition of the different frameworks. Now, a class library basically stores the class and makes the class available to all the developers who need to use it. So suppose you create a class called building, then you should be able to share it, and so that somebody else who is working in an architecture firm and needs to create a building plan, they should be able to use that class library. So the goal is to provide it with a package, which is the class library, so that anybody else can import those classes from that library. So it's just like your college's library. It has a lot of books. So you go there and you fetch different parts, different books, so that you can move forward with your studies. A button created from a class is called an object. So that's what we said. I mean, a class is a representation. It's a framework or definition or the blueprint of the real objects. But the button, for example, created from a class, it is called an object, or sometimes called the instance of a class. The process of creating a button object from the button class is called instantiation. The rapid application development is basically the process of using pre-built classes to make application development faster, easier, and reliable. So in a framework where you have many class objects, class libraries, so you don't have to define the framework for each and every. So let's say buttons, you have already somewhere in the button, you have to drag that button and integrate it to your program. So that kind of development approach is called rapid application development approach. Edu.NET ActiveX Data Objects provides the functionality for a program to perform 4 primary tasks: getting the data, examining the data, editing the data, and updating the data. ASP.NET allows developers to use Visual Studio to build powerful and sophisticated web applications. Using ASP.NET classes, programmers can create websites that perform any functions available on web. ASP.NET is designated for cloud technologies and server-side applications. Cloud computing is the connection of remote servers hosted on the internet to store and process the data. Basically, when you access the computer, the traditional way is to go to your laptop and use the physical device. In cloud, everything is served via internet. So you logged in some area and then say that I want this machine, I want a Linux machine, I want a Windows machine. It will be popped up. Just like, I mean, some people, I mean, some of the class, some students in the class may have been struggling with the Visual Studios because they have the MacBook. So for them, the solution is go to the library of East Los Angeles College, our college's library, where you will be able to launch an instance of a machine from your computer connected via internet, where you can create a Visual Studio. I mean, you can start a Visual Studio that is pre-installed, and then you start the development, kind of rapid development methodology, you know. So Microsoft Intermediate Language and Common Language Runtime is the when you compile a program, the program compilation translates programming statements into instructions that can be understood by the electronics of the computer, you know. And program compilation for a Visual Basic program creates a set of electronic code expressed in an intermediate language called Microsoft Intermediate Language, MSIL. When the program is executed, a portion of .NET called Common Language Runtime or CLR reads the MSIL, and then it creates the instructions within the program, and that actually drives the instructions within the programs to be executed. That drives the program execution process. So the Common Language Runtime, you can see here, I mean, it's basically, you see in the first screen the program, some functions in the program. It goes to the RAM and it is compiled. Then it goes to the MSIL storage on disk storage. It goes to the CLR interface, which lives on the RAM, and then it is served on the GUI screen. These are the steps. So there are different types of Visual Basic applications. You can use a Windows classic desktop application. That's what I showed you, in the Hello World. Even, I mean, what I showed you is also the command line application. It's not even the desktop GUI. There is a Windows Universal application, you know, then the web application and the database application. There are 4 types of application that is used by, created by Visual Basic applications. The Microsoft HoloLens development. HoloLens is the augmented reality headset that places 3D holographic images in your scope of vision. HoloLens apps are being developed using Visual Studio. To select car options at Volvo dealership, to create a custom kitchen at Lowe's Home Center, to explore other planets at NASA, to replace a flat screen TV with much larger holographic display. So the Visual Studio works with Unity software to build HoloLens applications and test them on a built-in HoloLens emulator. The emulator uses a Hyper-V virtual machine. Hyper-V is an example of the virtual machine to run the application. HoloLens are stimulated using your keyboard, mouse, or Xbox controller. A screenshot from the HoloLens is like that. So what did we understand here? We understood the fundamentals of computer programming and have been introduced to Visual Studio and Visual Basic program development environments. In the next chapters, what we are going to learn is to use Visual Studio and Visual Basic to create Windows classic desktop applications for Windows Universal application, database application, web or cloud applications for computer and mobile devices, and HoloLens applications. So we covered mostly the basics of the computer programming, touch base on computer hardware, software, and also presented some introductory concepts of Visual Studio, and then what are the opportunities, what are the scopes of our Visual Basic languages. And we can already see that Visual Basic can offer development of lot of languages, and it is for you, I would like to say, it widens a scope for your personal learning journey, and also employers do like Visual Basic. There are a lot of places they use Visual Basic. Go to bank, go to the grocery stores, everywhere people use the Visual Basic to develop their Windows applications. GUI applications, even for the websites. So I mean, the stage is quite create. I mean, stage is now set now for you to go into the system and start learning your basic steps of Visual Basic programming. Any question, reach out to me. If you want, you can set up, you can request for some office hours. I have already indicated my availabilities. I will respond to you on a first come first serve basis, but you may expect a response from me within 24 to 48 hours of sending an email. So we will be having more discussions, right? So for now, let's say let's go back to our study desk and study hard the first chapter. So you should be opening the book right now and start reading the first chapter. As you go through my lecture, you will find out the main important points. But now it is your responsibility to read the chapters, because we will have a quiz. I mean, go through the syllabus. You will find that we will have a quiz of chapter 1 and 2. Once both chapters are completed, we cover both chapters as lectures. So stay tuned, we will be here soon. Okay, thank you, bye.